Hi everybody, this is going to be our first Chapter 5 video, and it's going to talk about systems of equations, and we're going to be solving by graphing. So let's talk about what a system of linear equations is. I want you to pause the video right now. I want you to write down these definitions. So a system of linear equations is a set of two or more linear equations. Okay, so think your y equals mx plus b, slope-intercept form. Two or more linear equations combining or containing two or more variables. So that just means that you're going to have your x and your y variables. Now, we're solving systems of equations, so the solution of a system of linear equations is actually going to be an ordered pair. The reason for that is we have an x and a y variable that we're solving for, so we're really finding a point. We're finding an ordered pair, which is always x and then y. Now, the solution to a system of equations is an ordered pair that makes both of the equations in our system true. So let's look at what that actually looks like. Let's say that we had this system of equations here. We have two equations. Each equation has an x and a y variable. We want to decide if the point, the ordered pair 4, 1, is a solution to this system. To do that, we're going to plug in the x value of 4, the y value of 1 into each equation and verify that it makes the left and the right side equal to one another. And it has to be true for both equations, not just one, but both. So let's do it for our first equation. We're going to plug in 4 for x, we're going to plug in 1 for y, and then we're just simplifying. Okay, 4 plus 2 times 1 is 2. 4 plus 2 is 6. We get 6 equals 6, so it checks out. So we know that that point makes our top equation true. Now we just need to make sure that it makes the bottom equation true as well. So let's plug it in again. We plug in 4 for x. We plug in 1 for y. 4 minus 1 is equal to 3. So again, it makes the bottom equation true. Because it makes both equations true, that is what tells us that the point, the ordered pair 4, 1, is actually a solution to this system. Okay, so you would have to write that out. You would have to say, yes, this point is a solution. So let's look at another example here. Okay, we've got a point negative 1, 2. So that's my x, my y. And again, we're going to plug in those values to each equation and see if it makes the equation true. So we would have 2 times negative 1 plus 5 times 2. 2 times negative 1 is negative 2. 5 times 2 is 10. Negative 2 plus 10 gives us 8. So that point makes our top equation true. We just have to check the bottom equation now. So again, we're going to plug those x and y values in. 3 times negative 1 minus 2 times 2 should be equal to 5. So 3 times negative 1 gives us negative 3. Negative 2 times 2 gives us a minus 4. But negative 3 minus 4 gives us a negative 7, which is not equal to 5. So that point is not a solution to the bottom equation in our system of equations. Therefore, even though it was a solution to the top equation, this point is not a solution to the system. Now, an important concept here is to remember that a solution of a single linear equation are just the points that are on its graph. So if you think of a line, there are an infinite number of points along that line. Each one of those points, or ordered pairs, is a solution to that single equation. So when we're testing the solution of a system of linear equations, we're making sure that that point is actually on both lines, okay? The point that we're finding here is going to be the intersection point of the two lines of these equations that we're given. So we're really trying to figure out, where do these two lines cross? Where do they have the same shared point? If we can find that point, we know when both equations are the same, which means that that point is going to make both equations in our system true. So solving by graphing is a very, very nice method. If we want to solve this system of equations, remember we're finding an x and a y value, we want to find the intersection point of these two lines. So we're going to graph each of these. Okay, I'm going to do the first one in blue. So we're going to do our y-intercept at -3. It has a slope of 1, so you can do 1 over 1. So we're going to plot our points. We're going to connect our points together, put arrows on the end. And then we're going to graph our second equation. So I'm going to do this one in green. I've got a y-intercept of -1, a slope of -1 over 1. So we're going to start at our y-intercept, go down 1, right 1, get all of our points in. And again, we're going to connect the points. We're going to put arrows on the end of our graph. But to find the solution of this system, we are looking for that intersection point. We're looking for when these lines cross each other. So looking at it, it looks like our graphs are intersecting here at the points 1, -2. X value of 1, y value of -2. So let's plug those x and y values into each equation and make sure that that's actually the answer. Make sure that that is the true solution to our system here. So let's see, let's plug in 1 for x, -2 for y. So for the top equation, 1 minus 3 is -2, so that checks out. So that is our solution to the top equation. We just need to verify it works for the second equation. So we're plugging in -2 for y, we're plugging in 1 for x, and again, it checks out. So this point that we found, that intersection point of the two lines, the point 1, -2, is the solution to my system of equations. Okay? It's the only point that is going to make both of my equations true, because it's the only point that these two lines have in common. It's the only place where they're actually touching, where they're intersecting. So that's where we find the solutions to a system of equations. So the key ideas here when we're solving by graphing are we're going to graph each equation in our system. Okay, the solution to that system is going to be where the two lines intersect. We can have special cases of no solution when the two lines that we graph are parallel, meaning they never intersect. And we can have an infinite number of solutions when we have two lines that are exactly the same. If my two lines are exactly the same, that means that they're basically going to be graphed on top of each other, and they're going to share an infinite number of points. Therefore, they have an infinite number of solutions. Hope this video was helpful. Make sure you ask questions, pause, rewind, rewatch as you need to, and have a wonderful rest of your day.